Hey all, uh, so welcome to this talk. And in this talk, I'm going to share my experience of setting up a local MLOps environment, and that too from scratch. So, if you are watching or if you have landed on this particular video, I assume that you are already aware about this term called MLOps. And um, so, I won't be going into details of what exactly MLOps is or where do we want it, how is it getting shaped, what kind of designs we foresee. But just to cut short or just to briefly touch upon, you can always go back to various sites such as this one, mlops.org, and see for yourself the various definitions, like wherein here they are talking about having a machine learning model operationalization management, uh, where the intent is to provide an end-to-end machine learning development process to design, build, and manage reproducible, testable, and evolvable ML-powered software. So, in my understanding, or the crux is MLOps enables uh, an end-to-end journey of machine learning, starting from experimentation to the last mile where the model gets starts getting used or inferencing starts getting take place in production, that too for variety and volume of data and at scale in different varieties. So you can go through various such different sites like this one. This one also will give you a good insights about what MLOps is, how can you get started for it, what is the motivation, and there are various perspectives like the end-to-end ML workflow and the life cycle related to that. So, this can be a one good data source, or one good source to know more about MLOps, just in case. But most likely, since you have already landed on this particular video, so I assume that you are more interested to set up a MLOps dev environment from scratch with an intent uh, to, and I'm just sharing my intent. My intent was to have a local setup which I can use to try different perspectives of. So the another intent was to explore this this area of MLOps, because this is a very new. This is kind of getting shaped. There are many organizations which are now quite well advanced, and they want to put a lot of ML in production. So this becomes quite important, right? So it's good to know more about this, especially when it comes to hands-on. It's good to test out and explore and exploit what's there in market, and to try to try and test your concepts as well. So that's these are two main intents for me, right? So behind doing this exercise. So how I'm going to take you towards this journey, that's the intent of this particular small talk over here. So this whole I just thought to do this setup in two parts, or and that's how the whole set of these videos are divided as well. So in part one of this video, which is this one as well, part one, we are going to see basically the Kubernetes cluster setup. So this part one basically is like a context of it, or you can say it forms the basis of setting up the whole MLOps platform. As per my understanding, when you start talking about MLOps, there are few things which are, let's say, kind of de facto. So everywhere when you are going to see MLOps, you're going to deal with this term called Kubernetes, right? So it becomes a kind of an implicit arrangement that if there is a MLOps ecosystem, that is more likely to be on Kubernetes. Even though conceptually it's altogether a different thing, you could realize maybe altogether on VMs or different host machines as well. But it makes much more sense to have it on Kubernetes because that's where the whole cloud native journey is going to be, right? So part one becomes essential, and that's like setting up the base for this particular Kubernetes cluster. Part two then will be more focused around, we will be basically doing two main things in part two. We will be setting up the storage, yeah, storage configuration. So that is, for example, defining the storage class necessary for it. And eventually we will be setting up MLOps software, right? So in this case, I have chosen Kubeflow, which is an open source framework for bringing your ML models into the production. Well, in my view, it is not, it may not be an end-to-end, software for your all MLOps needs, but to majority or to an extent, yes, it does the job. And then later on, I would like to come up with maybe in later parts or later series of it, maybe let's say part three, about talking about various other components. Those could be considered as add-ons, and that will be in continuation to what we are going to see in these two parts. So those components could be related to feature store, right, and related to data pipeline frameworks. So we'll see how, and there could be many more things to enable our feature MLOps understanding. So I'm going to take pause right now over here, and then we are going to start without wasting much of a time. We are going to talk more about this particular part right after this.
Get started with this. And as aforesaid, in this part one, I'll be showing you how I installed Kubernetes cluster on bare metal. So I have this set of these three work servers or workstations, which are from HP Z620, 620, and I've already installed Ubuntu server 20.4.4 LTS OS on them, and they all have 32 gigs of RAM, 1 TB of hard disk, and equipped with a Intel Xeon processor. So quite a, mm, I would say, good enough configuration for our Kubernetes cluster and for our personal dev kind of MLOps workload. And these are the IPs which are associated to my machines over here. So as you see on the right side in this panel, this belongs to master, and these are to my worker nodes. So, and on the left side, this is a small documentation which I have created just to capture all the commands and the so that it's more legible, and we'll go through this as a in sequence of steps to show how I install Kubernetes, how I set up my Kubernetes cluster. So what is this all about? This is all about is setting up a Kubernetes cluster. And why Kubernetes? Because we know that uh, when in today's world, if anyone is going cloud native, uh, Kubernetes is getting de facto in terms of containerized worlds. And when it comes to MLOps, you would see majority, in fact, all of those frameworks getting installed or getting equipped to be deployed using Kubernetes. And the reason being that Kubernetes offers a wide variety of deployment variations, such as with the use of Kubernetes, you can have your MLOps ecosystem in multiple varieties in on-prem, hybrid, or cloud, entirely on cloud as well, right? And in this tutorial, we will see how a Kubernetes cluster can be installed on a set of bare metal Ubuntu server machines, right? Now, to know more about the Kubernetes and various options, you can always go to this particular site of Kubernetes, right? So maybe we can quickly have a glimpse of it. So what is Kubernetes? And it has a lot of documentation. It has a lot of information, right? So you can always go and check this out. So going back to our agenda. So before we actually start with our Kubernetes journey, these are just optional steps. You just need to prepare your workstations with Ubuntu OS, which I've already done with my Ubuntu server. And you can go and check this particular link over here to know more about Ubuntu server. And you can, in my case, I actually went for this option 2 for manual server installation, which is pretty straightforward. You can download the ISO image and then prepare your bootable USB disk drive and then use it for installation. Pretty straightforward. It would hardly take 10 to 15 minutes for your server to get ready with your Ubuntu server. So pretty straightforward and pretty intuitive, right? So let's go back to our journey then. And then some of the small logistic work. So I have already equipped my etc host in all of these workstations, so that I'll just show you like what I mean by configuring this etc host files. So I've already configured some of the aliases which I'll be using most frequently. Uh, so for example, we'll be using a common uh, uh, name for our Kubernetes cluster, which is control KTS, and it is linked with our master node. Then for our worker nodes, we have these IPs 199 and 208. So these are the aliases for worker nodes, worker 1, worker 2, and short aliases W1 and W2. Pretty straightforward thing, right? And then I don't like to pass, passwords each time when I'm doing SSH across them. So I have configured a password free entry by passing or supplying the keys, exchanging the keys amongst these workstations. Pretty uh, simple or usual admin task, right? So you can even ignore it if you want. So let's do this particular stuff over here, right? So we just got our servers rebooted. So let's proceed with our step 1. So now we are going to add the Kubernetes repo, and thereafter we will be installing our Kubernetes CLIs. We need some tools to install our Kubernetes cluster. And there are various options, there are various ways through which you can install Kubernetes. You can either build the whole Kubernetes cluster by yourself, or you can use certain utilities such as kubeadm, kops, kubespray. In this particular tutorial, or in this particular discussion, I'll be using kubeadm, right? So let's go ahead. So now I'm going to add the repo so that I can uh, and install these Kubernetes utilities. So let me add that repo to my servers. Now we are going to install all the required packages. Just a note over here. Uh, right now, Kubernetes is, I think it is released with 1.22 and thereafter minor versions. But then we are going to use Kubeflow in this particular setup later on. In the part 2, I'll show we'll be installing Kubeflow version 1.5.0, which is not compatible with version 1.22 and onwards. So therefore, we are going to install specific version of these CLIs, which is going to be 1.21.10, right? So now let's go ahead and do that. You can check the version of so this is just a sanity check. We just want to make sure that whatever versions we wanted to have, uh, do we really have those versions or something else, right? So, and it is also one way to check if your installation was successful or not. So yes, we wanted a minor version 21, and this is the 121.1.0, right? So in all the machines we have the same version, so that's pretty good. So now we are going to disable swap. So uh, now if you really want to know like why swap needs to be disabled while installing Kubernetes, you can always go back, go to refer to this particular issue. And this is mainly because in Kubernetes world, it requires a lot of resources, and this is just my understanding, right? And that's why, and swap is not enabled, and I mean swap is disabled, right? But you can check it out in more details, the reasons behind it, right? So I'm going to disable the swap now. First, we can see if this what is the status of swap, right? So with this command over here, we can see whether the swap is on or not. Yes, swap is on. Otherwise, this should not have shown anything. So let's disable the swap. What we can do is we can simply comment the entry related to swap in this particular file, which is etcfs tab. Now we can quickly check the status again, right? And there you see there's no output now. So we are good with this, right? Step 4, we are going to enable kernel modules, right? So, and this is just to, because there is a requirement for our Linux nodes, IP tables to correctly see the bridge traffic. So we need to ensure that bridge NF call IP tables is set to 1 in our CTL config, right? So I'm going to do that. Then we can just simply reload the syscontrol, sysctl, right? And there you will see that it would have taken up these configurations over here, right? So we are good with this, right? Now we are going to install the container runtime. So in Kubernetes, to run the containers, it needs a container runtime, and there are many container runtimes which are supported officially by container Kubernetes, right? But in this particular talk, I'm just going to talk about Docker because that's the container which I used, right? So in case you want to further check, you can always go back to that same documentation which we talked about, the Kubernetes documentation, right? So let's do that. Now we are done. Now we're just going to enable the services and start them pertaining to Docker, right? So let's do that. I'm just going to reload my daemon, right? And then here I'm going to restart the Docker service, right? And enable it. Cool. So now in case you want to see what is the status of Docker, so you can simply do this. Great. So this shows active and running in all the three servers. And yeah, we are good with this. So we are kind of done with the setup which is required in all the nodes, right? So next we are going to initialize our master node with step 6 onwards. Okay. So now since we are done with our basic configurations on all the worker nodes or all on the servers, let's go ahead with this step 6. Let's go ahead. Which is to initialize. So now on the master node, we just make sure that our BR net filter, which was a kernel module which we enabled, is it enabled or not, right? So let's do that, and let's just see if it is enabled or not. Yeah, this is enabled, and we can probably do one more check which is related to swap on. Let me just see if I still have, yeah. So yeah, swap is off, right? So that's fine. And then I'm going to enable the kubelet. And then I'm going to pull the container images. All right. So now since our images are pulled, right? So what we are going to do is we are going to bootstrap the cluster. This is the most important step, and this is the step when we are going to initialize a cluster, right? So the basic command is this one kubeadm init with certain arguments. Now there is a list of arguments which are supported by this kubeadm init, and those can be referred from this particular URL over here, right? But in my case, I'm going to use these most basic ones, or you can say the needed ones, which is API server advertise address, or the IP which I'm going to use as for my API server to be run, or to be known at, or that's kind of address for it. So then I'm going to use upload search, which is going to upload the certificates to all the worker nodes whosoever joins this cluster. And this is a pod network CIDR, which can be of any other range as well. So in my case, I'm using this particular range, which is going to be then associated or assigned to my pods. And then I'm going to say that my control plane endpoint is control-KTS. So this is an alias which we have given to our master node. If you would have recalled, like when I showed the etc host file, so this is the alias which is configured against the master node, right? So let's do that. Let me just run this command and see if we are able to set up the Kubernetes cluster or not, right? So what it does is it runs some pre-flight checks, and then it will show you all the execution, right? So it shows like what all steps it is doing, and it should not take much time. Yeah, so now we are ready with our cluster, and it shows that your Kubernetes control plane has been initialized successfully. So this is the stuff which you should notice, that this plane has been initialized, control plane has been initialized, and then it also gives you some more information, such as to use it as a regular user, we need to do all of this. and then we can also export, alternatively, we can also export the config file in a kubeconfig variable. So that's more like you're sharing that information to your environment. And then we can join the cluster in two ways. Either we can make another node as a master, and we can join this cluster as a master node or a control plane. So that will be like a HA master kind of configuration using this command over here, or maybe to join as a worker node, the command at the last, right? So I'm going to just copy this whole information because we are going to use this later on, right? So this is now with me, and let's proceed. So we are going to just uh, follow these commands over here. I'm just going to create this kube directory because we want to access this cluster as a regular user, right? So not all the time we want to use it as a sudo. So then I'm just copy the config file, which is by default is in this folder etckubernetesadmin.conf. I'm going to put it in my .kube directory, and then I'm going to add the necessary details or authorize my regular user to make use of it, right? So pretty straightforward stuff. And now we are good, right? So if I just do kubectl cluster info, I should be able to see some information related to my cluster. So let's check this out. Yeah, so it says Kubernetes control plane is running at this particular endpoint on this particular port, and this is a core DNS which is running at this particular URL, right? So then we are going to go ahead and if I just do this particular stuff over here, if I just want to know which all nodes are configured are part of this particular cluster as of now, let's see what it shows to us. Yeah, so it says that right now I have master which is in not ready state, and the role it is playing is of control plane and master, right? And its internal IP is this one, right? So fair enough, but it is not ready yet, right? And why so? Because we have not yet done the or added the network layer on top of it. So we are going to do next uh, is we are going to install the network plugin on the master node. And there are actually various supported network plugins which you can refer from this particular website, from official Kubernetes webpage. And as per your needs, you can choose any one of these, right? So in this particular tutorial uh, talk, I'm going to show you the Calico, right? So this Calico is the network add-on, pod network add-on, which I'm going to use. So you can simply run these two commands to install Calico. All right. Now let's see what do we have in our ports. Cool. So now we have all of these pods in running in healthy state. So let's go and see how about our node, right? So earlier our node was in not ready state. Now let's see how is my node doing. All right. So now if you see the node over here master, it is now in ready state, and yeah, that's it. And with a Docker runtime, right? So I think we are done. We are done with our master node initialization. Next, what we need to do is we just need to add worker nodes to it, and that's a pretty simple stuff, a simple task. What all we need to do is uh, in when we initialize our cluster, we were given a command to join any node as a worker node, So I'm just going to copy that particular command from my notepad, and I'm going to run that command from my worker nodes over here, right? So let me just clear the screen, and I'm going to run this as a sudo, right? And this was a command which I had. It simply says that I need to join this particular cluster with this token and this particular certificate, right? So let's do that. It should be okay. Now it has joined the cluster, right? Let me do that over here as well. All right, now let's do the get nodes once again, and let's see what we have for us. There you go. So now we have worker 1 and worker 2 over here, which are still in not ready state, right? So let's wait for a while. I'm just going to remove this O wide over here just to see in much more simple manner, right? So let me just put a watch on this as well. So I think we are done.